which is the signaling molecule proclaimed as the molecule of the year 1992. Do you know? Okay, let me give a clue. It is a blue gas. Can you find it? Yes, you are right. It is nitric oxide. So let us see few important points about nitric oxide and its pharmacological aspects today. So first, the introduction. It is one of the oxides of nitrogen with molecular formula NO, indicating that it is a free radical with an unpaired electron. Nitric oxide is the smallest endogenous signal molecule and the only one which is a gas at normal temperature. History of nitric oxide and its discovery. In 1987, EDRF was confirmed as nitric oxide. Here, EDRF stands for endothelium-derived relaxing factor. It diffused to the underlying smooth muscle cell, causing relaxation in them. Now let's see the generation and fate of nitric oxide. Nitric oxide is synthesized from L-arginine. On the action of nitric oxide synthase, L-arginine is converted into L-citrulline, which produces nitric oxide as a byproduct. Later, nitric oxide is converted into various other oxides of nitrogen like nitrite, nitrate. If nitric oxide reacts with superoxide, it produces peroxynitrite, which is very harmful substance for the cell as it causes lipid peroxidation and ultimately ends up with cell injury. So, in this process of nitric oxide synthesis and its fate, other compounds like molecular oxygen, NADPH, FMN, FAD, heme and tetrahydrobiopterin are involved. Nitric oxide is produced because of the action of nitric oxide synthase, and there are three isoforms of the same enzyme. They are neuronal nitric oxide synthase, inducible nitric oxide synthase and endothelial nitric oxide synthase. Here, the inducible nitric oxide synthase is not calcium dependent and is active as such. That is the main distinguishing feature of this isoform when compared to the other two. After the generation, nitric oxide exists in tissues only for few seconds because it rapidly reacts with oxygen to form other nitrites, nitrates as mentioned earlier. Another important point is that superoxide dismutase, which is a superoxide scavenger, enhances and prolongs the action of nitric oxide. Let's have a quick look on the actions of nitric oxide. So the first one is nitric oxide is a potent vasodilator. The second important action is that nitric oxide inhibits platelet aggregation and thus thrombus formation. Nitric oxide serves as a neurotransmitter also. Another important point regarding nitric oxide is that aberrant nitric oxide generation can play a causative role in degenerative neurological disorders like Huntington's disease, Parkinson's disease and etc. It also mediates the microbicidal action of macrophages. So next, let's move on to nitric oxide donors. So the definition is that those compounds which contain nitric oxide or a similar structure in their own composition, which can be released in the body mostly enzymatically to produce smooth muscle relaxation, and examples for such compounds are organic nitrates, nitrites and sodium nitroprusside. They are also called nitrodilators. Now let us discuss few features of nitric oxide as a therapeutic agent. Inhaled nitric oxide is indicated or it is required to be administered in severe respiratory distress in case of neonates with elevated pulmonary arterial pressure. It is dilator of pulmonary vessels, particularly in the areas of lung that are better ventilated. Thereby, it reduces the ventilation-perfusion mismatch and improves gaseous exchange. The elevated pulmonary artery pressure is lowered and thus cardiopulmonary function is improved. Moreover, inhaled nitric oxide improves cardiopulmonary function in adult patients as well with severe pulmonary arterial hypertension. Hope you all liked the video. Don't forget to like, share and subscribe. Thank you for watching.